Greetings to the LAJAK top management. We are Group 4 from Section 34, and the group mates are May Xin, Cheong Lai See, Wong Sok Wen, and me, Chua Shu En. Today we will describe the status of production in December 2020 in this meeting. So first, I would like to start the presentation by describing and summarizing the given sample data of pure LAJAK KURUIH-D produced in December 2020. First, we categorize the 200 sample data by using numerical method. You can see from the table here, we get the average, standard deviation, and variance of weight in milligram, relative density in percentage, and tensile strength in megapascal. And we arrange it according to the 3 different shifts, which are evening, morning, and night. Hence, we can get the overall data stated in 3 of the shifts in another table. Second, we analyze the sample data into tabular forms, which are weight, relative density, tensile strength, and shift. We categorize the data into several groups, which is easier for us to obtain the frequency in each category. After that, we apply this into graphical forms, which can provide visual summaries of data that help us more quickly and completely describing the data. From the histogram of 200 sample data, we can observe that the pairs which have weight between 340 to 350 mg has the highest frequency, which is 59. The highest frequency of relative density is 69, which is from the group of 86 to 88%. Besides, most of the pairs has tensile strength in the range 7.2 to 7.4 megapascal. Most of the sample production is taken from the night shift, which are 74 of them.
Hi, I'm Cheong Lai See. Now I will continue with question B. For question B, we are required to test whether the weight of the standard tablet produced by the manufacturer follow normal distribution with 350 mg with standard deviation of 40 mg or not. We arrange the data first. Since the data given is organized randomly, so we need to group the data and categorize it into the intervals such as table below. Secondly, we do the hypothesis statement. The null hypothesis states that the weight of the standard tablet produced by the manufacturer is normally distributed with 350 mg with standard deviation of 40 mg, while the alternative hypothesis states that the weight of the standard tablet produced by the manufacturer is not normally distributed with 350 mg with standard deviation of 40 mg. After that, we tabulate the data, where the range of the data are converted into the probability by using the formula x minus 350 divided by 14. To verify that whether this table is in proper or correct method, we use the summation frequency from the grouping data to verify it. We can clearly see that the summation frequency of OI and EI are equal, which is equal to 200, and also the summation of each probability which show value 1, showing that this table is correctly verified and ready to be used. To find EI, we can use the formula n multiplied with PI, where n is the total observed value, and PI is the expected probability we calculate. Since there are EI less than 5, we need to merge the data. After merging it, the new observed value OI prime and the new expected value EI prime are obtained. We can obtain the chi-square test value from the summation of OI prime minus EI prime squared divided by EI prime. We use the significant level alpha equal to 0.05 and the degree of freedom V equal to K minus P minus 1, where K is the number of category which is equal to 6 and P is the number of unknown parameter which is equal to 0. Since there is no unknown parameter, then the degree of freedom is equal to 5. The test is one-tailed test when H0 is rejected if the calculated static chi-square test is greater than the critical value, which is equal to 11.0705. To make decision, we found that the chi-square test we calculate is equal to 2.9954, which is smaller than 11.0705, which means that we fail to reject hash node. Hence, we can conclude that at alpha equal to 0.05 level of significance, there is significant evidence that the LAJAK tablet produced in December 2020, regardless of shift, do follow this distribution.
I'm Wong Sok Wen. I'm going to explain about the Part C, which is comments on whether there is any significant difference between the tablet weights for the different shift. So we decided to use the one-way ANOVA test to determine it. And before we proceed with the ANOVA test, we need to make a hypothesis statement. In this case, we assume that the alpha is equal to 0.05. And for hash node, we assume that there is not significant difference between the tablet from the different shift, which μ1 is equal to μ2 and is equal to the μ3. For hash 1, we assume that there is a significant difference between the tablet weight from the different shift, which μi is not equal to μj for at least one ij, where I is not equal to j for ij equal to 1, 2, and 3. By using the data analysis tool, we can obtain the following result, and this is a summary table, and this is the ANOVA table. In the ANOVA table, SS is the sum of square, DF is degree of freedom, MS is the means of square, F value, P value, and F critical values. As we can notice that the p-values is 0.2367, and we can use it to reject the hash node if the p-value is less than alpha value, which is 0.05. So we can notice that the F value is equal to 1.4515 and F critical values is equal to 3.0418, and also we can use it to reject the hash node if the F value is greater than the F critical values. As we can notice that the p values is greater than the alpha values and the f values is less than the f critical value, so we fail to reject the hash node. So we can make a conclusion that at alpha equal to 0.05 level of significance, there is not a significant difference between the tablet weight for the different shift.
Hi, I'm May Xin, so I will continue with question B. From the question, tensile strength depends on the relative density and regardless of the production shift. So we can use the method of correlation analysis and test for linear regression to solve this problem. Independent variable x is the relative density, dependent variable y is the tensile strength. By using Excel, we can obtain the analyzed data as shown in this figure. So we can get the value of alpha hat and also beta hat. So from these two values, we can obtain the linear equations. We can also obtain the graph as shown in this figure. Based on the graph, we can know that the prediction is valid for the relative density in the range of 82% to 94.4%. From the question, we need to predict the tensile strength for relative density of 68%, 74.3%, and 82%. For these two values is out of the range, so the predicted output is invalid. For 82 is within the range, so the predicted output is valid. For correlation analysis, we can refer to the data. The correlation coefficient R is equal to 0.8444, which shows that there is highly strong positive linear relationship between the relative density and tensile strength. For R-square value is equal to 0.713, which indicates that 71.3% of original uncertainties in the value of tensile strength can be explained by the linear regression model. Thus, the linear regression model is adequate. From ANOVA table, we can test the linearity based on the value of f-test and t-test value. In this case, the significant f is less than the level of significance, which is equal to 0.05. Therefore, we can reject hash node, and we can conclude that at level of significance equals to 0.05, the data provide a strong evidence on the existence of linearity between the tablet relative density and tensile strength. So that's all from our group explanation. Thank you.